Today we're going to look at the surface area for a cone, a sphere and a cylinder, and where the formulas come from. So if first up we take a cone, and it's not that clear on the board, but if you give your best shot of drawing a cone, the important measurements are the radius and what's called S in the diagram in the formula, but it's the length of the sloped side. So here, I'll make it bigger, is the S there. Alright.
So you want us to draw that?
Yes, please give it a shot. Now note that some questions might only give you the radius and the height. The height is the vertical height of the cylinder. If you only get the radius and the height, you'll then need to use Pythagoras to find S. Because the R and the H are the two sides of a right angled triangle, and S is effectively the hypotenuse.
So we're just drawing a net of that. So we're just drawing a net of that. No, just draw that.
Draw that. If you wanted to, you could do a net. The net would look a little strange, but you could do a net. Now, if you want to calculate the curved surface area, so for calculating the curved surface, imagine it is an ice cream cone. So it has no top, it's just the curved surface. If you want to calculate the curved surface, the area is equal to pi r s. So that is pi, which we all know. What's happening here? R is the radius of the circle, and S is the length of the sloped side. And make sure both R and S are in the same units. To make sure they're either both in centimetres or millimetres or metres. Now the area of the curved surface plus the base, so imagine an ice cream cone with a lid on it, is the area of the curved surface, so pi rs, plus the area of a circle, pi r squared.
Is there any way you can make that writing bigger, like the actual typewriting? I can't read that.
Yes, I probably can. Better?
Yeah, that's good.
I'll do that with the others. Right. Now, once you've got the cone down, have a go at drawing a sphere. Make that writing bigger too. And a sphere, we only have one measurement to consider. And that's the radius. What's it?
Is that one?
Yeah?
Because I've got all this stuff
Already?
in my appendix.
Nice.
So I just write C appendix for it.
Yeah, for the evidence, the appendix. Also do the cost in the next line if you have room.
Okay, yeah.
Alright, so surface area of a sphere is given by 4 pi r squared.
How'd you get it full?
It's the equation.
Good question. It's just the equation. And unfortunately showing you where the equation come from isn't in the course. Okay. However, the next one, given that the surface area of a sphere is 4 pi r squared, what might the surface area of half a sphere be?
2.
Yeah. Except remember, if I do a drawing of half a sphere, then the curved bit, this bit here, yeah, can be given as 2 pi r squared. What about the base? Because remember, the base still counts. If we're doing half a sphere, we've got the top curved bit and then a flat base. So our flat base in green. How would we find the area of that base? I'll give you a hint. What sort of shape is the base if we're going to cut a sphere in half? Yeah, it would be a circle. How will we find the area of a circle? Yeah, pi r squared. Alright, last shape that we're going to look at today is a cylinder. And I'll make the writing bigger for you. Wow. Alright. And it's important in questions to identify which sort of cylinder you've got. Is it just the curved surface, like a toilet roll, so neither ends count? Or is it a curved surface with one end, a bit like the bin next to my desk, so the bin has a bottom but no top? Or is it like one of those 44-gallon drums that has both ends and the curved surface? Alright, now you might not be able to read those measurements, but the two important measurements are the height, h, and the radius of the cylinder, r. Now, if we just want the cylinder, as in toilet roll style, we just want the curved surface, the area is 2 pi r h. And that one's easier to explain where it came from, because if you had a net, the net would look like this. It would be a rectangle with two circles, and those two circles are the lids of the cylinder, whereas the rectangle is the curved surface going around. And if each rectangle has a perimeter of r, if each circle has a radius of r and the height of the cylinder is h, then the length of the rectangle is going to be the perimeter or the circumference of the circle. And we find the circumference of the circle by 2 pi r. So this length here from there to there is going to be 2 pi r. So if we want to find the area of that rectangle in general, it would be 2 pi r times h, which is where that formula comes from. Alright. Now if we do the curved surface plus one end, our area is equal to 2 pi r h for the curved surface, and how much would we add on if we just want to add one end?
Plus pi r h.
Close. What is the end? What shape is the end?
Pi r squared.
Good, Vicky. Pi r squared. And what if we added two ends? 2 pi r squared. Alright, now using those formulas, I'd like you to go to page 124, do question 1 to 5, and then When you've done that, we'll do questions on folios if you have any.